The buck converter is simply a half bridge plus a filter. So the two have different roles. So the half bridge divides the voltage so that we get this voltage as we want. So we switch the switches in order to control Vm, which is the voltage between the switches. So if we look at that, you can see that we will get a square wave. That Vm is equal to a square wave. And that is because when the switch is on, let's say that the gate signal is 1, then we would have that Vm would be equal to the input voltage. And the reason for that is upper switch is on, this would just become a wire. So this voltage becomes equal to this voltage. And then when the switch is 0, then this switch would be off. And this switch would be on. So this voltage would become equal to this voltage. So then we would have a Vm equal to 0. So basically by controlling the gate signal, we would be able to control the voltage of Vm, but it would have this square wave. So that is why we want to add a filter afterwards. So this is a LC filter, so it's basically an inductor with a capacitor. So what it does is that it removes the harmonics so that we get a constant output voltage. So the output voltage could be something like this, straight, or it could have some ripple or harmonics. Like ideally, you would always have some ripple and harmonics. Now, if we look at how the current works, now we can also look at where the current goes. So this is basically what I just described, but here we look at the current. So when the upper switch is on, you can see that the current goes through the upper switch into the inductor and then into the LC, into the capacitor and the load. And then it goes back to the source. And then when the upper switch is off, then you can see that it goes only here. It goes through the lower MOSFET and then into the inductor and then through the capacitor and load. So here you can clearly see that Vm would in this case be equal to 0, and here it would be equal to the input voltage. Now, if we look at a plot of this, you can see that when the gate signal is high, we'll also get a Vm which is high. And if we look more into detail on this, I have a simulator. You don't need to understand much of how it works. Just understand that we have an input voltage of 100 volts. And then we have a target output voltage of, for example, 50 volts. And then we have a filter and a load. And like the target of this buck converter is to control the gate signals so that we get the output voltage that we want. So that is basically what this controller does, but we don't need to go into detail on how this works now. And then I will just run this simulation. And then you can see that we get the results. So basically here we have the gate signal, and then we have a duty cycle. So the definition of a duty cycle is basically the average of the gate signal. So then you can see that we get a 0.5 duty cycle here, where the gate signal is basically on as much as it is off. So here we have a duty cycle of 50%, which means that 50% of the time the gate signal is on, and 50% of the time the gate signal is off. And here we have the voltages inside the circuit. So Vm is the voltage between the switches. So it's this voltage here. And then the green one is the output voltage. So you can see that the filter averages the Vm so that we get a constant output voltage. In here I made a sweep so we can actually change the reference voltage. So when we increase the reference voltage, you can see that we get a higher duty cycle. So here it's 80%. So the gate signal is more on than it's off. And then we can see that the similar thing happens for the voltages. So Vm more high than it's low. And the output voltage is approximately 80 here as well. And then when it's low, you can see that when it's 20 volts, then we get the opposite thing. And here in this case, we have that, and in this case, we have that the filter is very strong. But if we reduce the filter, for example, if we put 1 here and 0.1 on the capacitor, and then we run it again, you can see that the filter is basically gone. So here we only have a half bridge. There, the output voltage would just become a square wave, and the filter basically has no effect when it's so low. In the next video, I will go more into detail on how the current behaves and the importance of the inductor itself and how it influences the current. So this will be the chapter 2, as you see here. Now, if you're interested in this course that I've been making about the buck converter and how it works, you can go into the link in the description. Or if you're maybe interested in this buck simulator, you can also find it in the description.